Good day, this is Edric of MIDAS IT. Today we're going to do a basic training on MIDAS Design Plus for reinforced concrete design. This webinar includes the introduction to Design Plus, the MIDAS Gen link to MIDAS Design Plus, and then we're also going to do slab design, beam design, column design, and footing design using Design Plus, which includes the detailed calculation and the drawings for each structural component. Design Plus is a collection of handy structural component design and detailing tools, which are easy to use and speed up the day-to-day design process. It is also developed to be simple, fast, and accurate. It also caters to the design needs of the engineers for quick and efficient design of various building components such as beams, columns, staircase, steel connections, slabs, basement walls, footing, etc. And then after obtaining the design results and the detailing, you can also obtain the AutoCAD drawings for the uh, design items. Also, the user can easily perform the parametric study by easily modifying the design parameters and cross-section. So, um, you can link your Midas Gen file to Design Plus. So, for example, you want to design a certain beam, so you just select it to the Midas Gen model, and then automatically Design Plus uh, will identify that member or node number, and then it will import the material properties, section properties, as well as the loadings. So here are the uh, included design modules for ACI 318 and AISC, LRFD, and ASD. For RC design, it includes slab, beam, column, shear wall, footing, etc. And then for steel design, beam, column, base plate, bolt connection, etc. Also, it includes SRC or steel reinforced concrete for composite beam, composite column, and CFT column. You can also generate detailed calculation of each structural member. So, so in the detailed calculation, you can see all the formula that is being used to design or to check that structural member. Also, you can generate the summarized report, which is a more simpler um, and it is in a tabulated format. And then both of the summarized report and detailed calculation can be exported to an MS Word report. Also, you can generate drawings of each structural member. So here are the sample drawing that can be generated to Design Plus. The for corbel, stair, footing, column, beam, and shear wall. So let's go now to the Midas Gen link to Midas Design Plus. So here is the framing plan of the model that we are going to use in this webinar. This is the foundation plan, second floor framing plan, the roof deck framing plan, roof framing plan, and then the elevation. And here are the material and section properties that we're going to use. So we have a concrete strength of 3000 psi, thickness of slab 100 mm, and then here are the list of beams and girders as well as the columns that we use in in the model. Also, here are the loads that uh, we use in the model. For the dead loads, we have the self-weight and the floor load. Also for live load, we have the floor load as well, and then the seismic load parameters that we use in the model. So here's the sample minus gen model that we are going to use in Design Plus. And as you can see, it already have the material and section properties as well as the loadings. So to add the material and section properties, you can go to Properties tab and then click Material Properties, click Add, select the type of design, concrete, standard is ASTM, and then DB will be grade C 3000, and then click OK. And then to add the section properties, go to Section Properties, click Add, select the shape, select User, type the name, and then type the dimension of the sections, and then click OK. To create the nodes and elements, you can use the node element tabs and use the basic commands for creating nodes and elements. Or you can go to structure. By using base structure, you can generate a frame model, and then by using building generation, you can generate the whole structure. Then to add the boundary conditions, go to boundary tab and define the supports. And if you want to release some beam element, you can use this beam and release. Let's see. So here in beam and release, you can select what forces you need to release on that certain element. Also, if you want to consider the panel zone effect, you can click panel zone effects and then set your panel zone effects. And then by the use of these panel zone effects, the forces that you will get in your for example in your beam will be from the face of the column up to the other face of the column. So not necessarily from node to node, but at the face of the column. And then to add the loads, go to Load tabs. First, you must define your static load cases. So in this model, I just defined 4 static load cases, namely DL, LL, DL for dead load, LL for live load, EX for earthquake along X, and then EY for earthquake along Y direction. Then you can also add the self weight. So direction will be at Z with a factor of -1. Also, you can convert your loads to masses. You can convert the dead load into masses so that um, it will add up to the self weight to calculate the W for the computation of base shear. Next, you can also assign floor loads. So we define floor load type. So define your floor load, your live load, and then the load on the roof deck as well. And you can add more. Also, you can add more loads, like for example the CHB, you can use this element beam load or line beam load. For the seismic, you can click this seismic loads, click add, and then input all the parameters. For example, we are using UBC 1997, soil profile, SC, zone 4, seismic source type A, 10 kilometers, importance factor is 1. For the period, click period calculator, and then this first formula is for steel, and then the second formula is for concrete. So this is what we're going to use, since we're using concrete design. And then the last formula is for other structures there, and then ductility coefficient, dr, and then the direction factor. So for example, ex, and then accidental eccentricity, you may select a positive, negative, or none. And then you can also view the seismic load profile here. So as you can see, there are no forces yet, since we haven't defined our R. Let's define the R. 8.5 seismic load profile. So there you have now your story force at each level, story shear, and overturning moment. The same procedure shall apply to EY, and then click OK. You can also add or you can also convert your self weight into masses, so that it will add to the computation of the weight to be used for the calculation of base shear. Once you have done in your modeling, you can now perform the analysis. So go to Analysis tab and then click Perform Analysis. And then after that, go to Results, define your load combinations. So we're doing concrete design, so I will go to concrete design and then click auto generation. So this auto generation will automatically generate your load combination based on the code that you define here. So for example, let's use replace, and then design code is ACI 318-14, and then click OK. So there are the load combination that will be used for the concrete design. But if you want to manually input the load combination, you can use the spreadsheet form and just type the name and then what load combination type it is, strength or service, type the factor here. So for example, DL will be 1.4 and then the rest will be 0 at the first load combination, and on the second load combination DL is 1.2 and then LL is 1.6. Another thing you can do is you can generate this format to Excel and then copy from Excel and then paste it here, but make sure you are in the spreadsheet form here, spreadsheet form. So after you define your load combination, you can now go to design, in the design you can go to RC design, design code, and then set the design code parameters for the RC design. Also, you can define your concrete material. So for example, it has a grade 40 main rebar and then grade 40 sub rebar. Then click modify. Next will be the design criteria for rebar. So for beam I use 16 mm, and then also for the column 16 mm. And then DT DB will be from the um, DT is from the top of the uh, beam up to the center of the first layer of the rebar. As well, DB is for the bottom of the beam. DO is for the faces of the column up to the center of the first layer of the rebar. So in here I use a 40 mm concrete cover plus 10 mm 10 mm stirrups plus the 1/2 of 16, which is 8, so that will be 58 mm. So after you plug in all the design parameters, we can now go to concrete code design and then perform the beam design and column design, or you can go to perform batch design and then check the concrete beam design and concrete column design. Click run, and then as you can see, you have now your design results for beam and column. So let's see the graphical presentation. This is for beam, and then this is for column. So we can now proceed to our main topic, which is the design plus. Actually, you can also perform the design of beams and column in design plus. So if you go to tools, and then if you click design plus, this will automatically open the design plus, and then you can link this MIDAS gen model to design plus, so that you can get all the forces of, for example, of a specific member. So let's go to design plus. So let's create a new model or new file. So if you go to mode link, you can see the MIDAS link. If you click MIDAS link, it will appear the MIDAS gen file that is open. So just click it here and then click connect, so that once we select, for example, a certain element, it will appear here in the member, the element number. Then you can now proceed to the design of that specific member. But first, so we go to option tab, and then let's just arrange first the design option. Drawing option. So let's uncheck this RC beam and girder and RC column in the non-scale drawing, so that it will generate a scale drawing. So click OK, and then for the rebar option, let's use IS, and then for the beam and girder, let's just stay at 16. Also for the column, so click apply, and then option. So let's select design code as ACI 318M-14. and then click apply. So after we have set our preferences in our design, we can now go to the design of structural components. So the first we're going to do is the slab design. So here is the slab that we're going to design. So for example, this part for the two-way slab, and then this part is for the one-way slab. So for the two-way slab, it is a 5x3 by 100 mm, and then for the one-way slab, 5 by 1.5 and then by 100 mm. So click slab and then click slab, and then in here you can see that all we need to do is to input all the parameters of the slab that we need to design. So for example, concrete will be 20.7, rebar will be 276. Then let's use a live load of 3.5, dead load I mean 3.5, and then live load of 1.9, and then that is 3 by 5. Thickness will be 100. So as you can see, all we need to do is to just input all the geometry loads as well as design parameters, and then you can also see that the drawings are automatically changing according to the dimension of our slab. Slab type will be two-way slab, and then support condition, so let's say here, and then boundary beams, so let's use the 250 by 400. Also you can use a different beam. For example, this B1 has a different width with B2, so uncheck this and then you can modify the other one. So let's say this is 200. Yeah, and then also you can select what type of bar arrangement you can use. Type A is like this, so it has a top bar, a bottom bar, and then this bent bars. Type B, so the top bars are now continuous. Type A, the top bar is discontinuous. Type C, so it only the top and bottom bars continuous on both direction. So let's use type A and then click design. So design plus will ask you what diameter you are going to use. So for example, you are using 10 mm, so these are the results. If you're using 10 mm plus 12 mm, meaning that the reinforcement are alternately 10 mm and 12 mm and so on. So just use 10 mm and then click OK, and then you can now view the results here. If you want to view the detailed calculation, so click detail and then you can see here the calculation. Also, you can save this as a Word format, so just click this Word and then you can modify that MS Word file. So that's for the two-way slab. So let's add another one. So go again here, slab, right click and then click add. So we go to S2 and then same procedure. That will be 20.7 to 76. Dead load, live load, and then span will be let's use the one-way slab here. So we will be using a span of 1.5, thickness 100, and then a concrete cover, so let's use 20, and then for the support condition let's use this one, prop. Then click design, let's use 10 mm and click OK. So what are we going to input here is the smaller length, which is the 1.5, because the from the PowerPoint presentation it is a 5 by 1.5 meter, so the 5 meter is along this direction, and the length to be considered is the width of the shorter direction of the slab, so that is the 1.5 meter. So let's see the results here, and you can also save this as a Word file. So we have now our slab, and then now we can now generate the drawing. So click go to drawing, and then set the drawings to RC, and then what element, slab, and then click create, and then automatically it will generate drawings, which is can be saved as a DWG file. So that is for the slab design. So we can now go to our next topic, which is the beam design. So to perform the beam design, we need to select all the beam elements for our beam design. So let's use this selection filter by direction. Let's select all the elements parallel to XY plane. Select all, and then automatically when you change this RC then beam, it will automatically detected by Design Plus all the selected element in MIDAS Gen. So let's check. It is 1 to 38, 59 to 89. Let's double check. 1 to 38 59 to 89, and so on. So it's the same. After that, click option, and then here in link data, so let's just use the section name, so that is percent s for the name of the element, and then member data, let's check this apply link option by member, then link by section, and then click OK. And then after that, click import, or keep section and bar data, and then click import. And then as you notice in the works tree, under beam, so you have now your B1, G1, G3, G2, but you can modify this by just dragging this G2 on the top of G3, so it will be arranged like this: G1, G2, G3, as well as this one. Or yeah, like that one. And in here you can check all the inputs from, for example, in B1 you can see that the concrete strength is 20.68, or the 3000 psi, and the main bar is 275.8, or the 276 MPa. The width and the height is 200 by 400, and then concrete cover is 40. This one, compression bar, this is for the doubly design, if you want to consider or do not consider a doubly design. And you can also apply special provisions for seismic design. And then the forces here are from MIDAS Gen, so no need to change this. And then let's check G1. So G1 has a 250 width, and then these are the forces from both end, critical on both end and critical along the middle. So the forces here are not necessarily at the face of the column, but somewhere near that end, whichever is higher. And also for the middle, somewhere in the middle, but not directly in the L/2 of the beam. And then I will introduce you the member list tab. In member list tab, here you can modify all the section in a tabulated format. So as you can see, the FC prime, FY, FYS of the beams, the dimensions. So what I'm going to do is to check all the seismic design for each member. So for example, at FTB I will be designing it as a seismic design. So let's just add all. And then that's it, and then click all, and then click check. And then at the end of this table you can now view the results. So some of them are failing in shear design, but in bending design or the top and bottom bar design are all pass. So if there are necessary changes in your geometry or reinforcement, you can actually, for example, at FTB, you can actually change this. Example, this uh, stirrup, let's use 3 leg or 4, then change the spacing. You can do that. And then, so we go now to the drawing tab, and then just go to RC and then beam for the structural component, then click create. So it will generate now your drawings for the beams and girders from FTB to B1, G1 up to RG3. Also, if you want to generate the detailed calculation for the design of beam and girders, so go to member list, all, click all, and then click check, and then click report, and then click this word detail, and then it will automatically generate all the report for all these structural component, or for this for the design of these elements. So we can now go to the column design. So let's just change this to RC beam and then column. So for column design, let's change the selection filter by direction to Z, and then select all the elements parallel to Z direction. So that will be 39 to 58, 92, 109, so on. 39 to 58, 90 to 109, so it's the same. Click option, and then link data will be %s, and then member data, check this apply link option by member, and then select link by section, and then for the load combination type, let's use this one, all, meaning all combinations, and then we'll just remove any duplicate load combination. Click OK, and then click import. So you have now your 3 columns here, C1, C2, and C3. So the procedure are the same, just need to modify if there's a need of modification here. So let's apply the special provisions for the 3. So go to member list, and then this one, let's check the seismic design. Click all, and then check. So that's it, and then let's check each member, C3, C2, C1 here, and then to generate the report, click all, and then same as the beam design, click click all, and then click report, then click word detail to generate the word file of the detailed calculation of the columns. For the drawings, same process, go to drawing tab, then just change the component from beam to column, then click create. So again, it will generate your columns. So if you need some changes, you can just modify the drawings. For example, here you need to, or here you want to add some reinforcement here. So let's try copy. There. So as you notice, it's the same command as the CAD. So that's for the column. So we go now to the footing. So change from RC column to RC footing. And then we must select all the nodes at the bottom of the structure. Select all the nodes, and then so in Design Plus it will automatically identify the nodes that are selected in MIDAS Gen. So option, click option, and then for the link data, so let's just use this member data. So apply link option by member, then link by section, and then load combination, let's use all. And then for the design force type, we must use the reaction of support. Then click OK, and then click import. So what I'm gonna do is I will modify the section in member list. So I will just change the compressive strength to 20.7, and then Fy is 276, which actually I can copy this, Control C, and then Control V here, as well as this part. Then what else? The height. So let's use a 1.2 height from the top of the footing to the NGL, and a depth of 300, so that makes a 1.5 depth from the NGL up to the bottom of the footing. Cover, let's use 80. For the rebar, let's use 16 mm at 200. We can copy this, Control C, Control V, again here, and copy all of this. So that is for the Y direction. Then for the X direction, space, and then for C1, C2, or the F1, F2, let's use a 1.2 length along X and along Y. So that is a square footing. And then for C3 or F3, 1.5. And let's use a bearing capacity, that is Fe here. Let's use 150. And let's check if those assumptions are adequate. Click apply, and then all, then check. So all of them pass from soil capacity to bending and shear design. So there are other type of footing that can be designed here as well. Like for example, isolated pile or line or wall. Also, if we go to RC, you can use combined footing if there are two columns that needs a combined footing. So that's for the uh, footing. So if you want to generate the report, again click report and then click word detail. If you want to view the summary, or if you want to generate the summary, you can click word summary. Then go to drawing to generate the drawing, then change the component from footing from column to footing, and then click create. So there you have your uh, footing schedule. So as you can see, H is from the NGL to the top of footing, and D is the thickness here. So if there are any modification, you can save this as the WG, then modify it. So if there are other structural components that you need to design, you can do it here in Design Plus as well. For steel, you can have beam and column, base plate, bolt connection, and others. Also for SRC, you can also do a reinforced slab, beam, and column here. So it means that your, for example, this slab has a reinforcement uh, beneath him, an FRP carbon, or here for the beam reinforcement on the face. So this is actually can be used for retrofitting as well as columns. So that's it for today. I hope you'll learn a lot from this webinar, and if you have more questions, you can reach us through our Facebook page, MIDAS IT Philippines, or email us at pageinquiry@midasit.com. So that's it. Thank you and stay safe. God bless everyone.